So our project now here is focused on the design and implementation of a fire detection and safety system using digital logic circuits. And our objectives include the design of fire detection system that can identify hazardous conditions based on multiple input signals. Like here, our input A is the smoke sensor, and B is the heat sensor, C is the flame sensor, and D is the manual emergency button. And we also got the appropriate outputs, that is the X, audible alarm, and Y, automatic water sprinkler activations. That is our outputs. So output X, that is the audible alarm, will be activated when a fire condition is detected to alert occupants, and output Y will be activated when critical conditions are met to suppress the fire. So now I will start to demo and explain about my circuit. That is, we got 4 inputs here and then 2 outputs here, X and Y. And now we have used, first we'll use the OR gate to connect the output A and B, and then also another OR gate to connect output C and D, and then we'll connect to this OR gate, and then same as for the output A and B, and then we just connect to our output. Now for the output X we have completed, and then the next also will same as the way to connect the output Y. And for the A and B, we'll use the AND gate first, and then for the C and D, we will use another OR gate. And now we just connect to another OR gate. So same as this one. And then we'll connect eventually to our output Y, and then this is our basic logic gate. Now we'll need to set the waveform, so just drag the hole here, and then we'll insert the value. So here, for example, I'll use the 160, and then for the second, I'll use the 320, and for the output C, we'll set to 480, and for the output D, we will set to the value of 640. So now, we just need to run the functional simulation. So this is the result of running of simulation, and then we can compare it and check it with our truth table. Like for example, when input A is 1, B is 0, and C is 0, D is 0, our output X will show the result 1, and meanwhile output Y will show the result 0. NAND gate at first, and then we got, and what we need to do, what we have done is we connect each input to a NAND gate first, and then we connect the NAND gate to another NAND gate. That is our output X. And for output Y, for the input A and B, we got connected into a NAND gate together, and then another NAND gate for input C, and another NAND gate for input D. And then after that, we just connect the AB and also the input C and D together. So that is our output Y. So now we need to set the waveform and run the simulation for the NAND gate. And same for just now, for A we'll set 160, and the value B is 220, and then input C is 440, and input D is the 640. So this is the running of functional simulation and of NAND gate, and we can see that it's actually same as for the basic logic gate before.